All right, subscribers, welcome back to another episode of Science with Surbeck. Today, what we're going to do is some extra percent error practice. Now, in our percent error, we have to remember a couple of things. One is the formula. So remember from notes that our percent error is equal to the absolute value of the error divided by the accepted value times 100 to get us into a percent. Now the error, if we remember from notes here, the error is equal to the measured value and I'm going to write value below, so measured value minus the accepted value. And again, I'm going to write value below. So problem number one says three measurements of 34.5 meters, 38.4 meters, and 35.3 meters are taken. If the accepted value of the measurement is 36.7 meters, what is the percent error for each measurement? So we need to break this down into essentially three different problems. And so I'll start here with measurement one. Okay, so in measurement one, we first need to find the error. Okay, so the error in measurement one is going to be the measured value, which is 34.5 meters, minus the accepted value of the measurement, which is 36.7 meters. So we put that into our calculators here. And so we have 34.5 minus 36.7. We press enter and we get negative 2.2 meters. Now again, don't worry about the negatives because our formula will work that out. So our percent error, and to save some room, I'm just going to call that percent E, okay, is equal to the absolute value, so negative 2.2 meters divided by the accepted value, which again is 36.7 meters, times 100. Now, what we do here is this. The absolute value of a negative number is positive. So I'm going to go ahead and just put 2.2 divided by 36.7. I press enter. I multiply that by 100, and we round here to 2 decimals. So the percent error on measurement number one is 5.99%. Okay? Now, we need to do the same thing for measurements 2 and 3. So for measurement 2, we start out with the error. And to calculate the error, you are going to take the measured value of measurement 2, which is 38.4 meters. We put 38.4 meters minus the accepted value, which is still 36.7 meters. And we find that error. So we do 38.4 minus 36.7. We press enter. We get an error of a positive 1.7 meters. Again, the plus and minus sign does not make a big difference because you plug the error into those absolute value bars. So here we have the absolute value of positive 1.7 meters, which is still going to be a positive 1.7 meters, divided by 36.7 meters because that is our accepted value, times 100. So what we do in our calculators is we take 1.7 divided by 36.7. Once we get that, we multiply it by 100, and we get a percent error for measurement number 2 of 4.63%. Now, we need to do this for the third measurement, so we always start out here and we find the error. So the error for measurement number 3 is found by taking the measured value, which is 35.3 meters, minus the accepted value, which is still 36.7 meters. And we plug that into our calculator. So we take 35.3 minus 36.7. We press enter and we get a value of negative 1.4 meters. Again, the sign doesn't really matter because the absolute value makes our sign positive. So our percent error here is negative 1.4, or the absolute value of negative 1.4, which is positive, divided by the accepted value, which is 36.7 meters, times 100. Okay, so again, the absolute value of negative 1.4 is just a positive 1.4. So that's what I'm going to put in my calculator. We divide that by 36.7. We press enter. We multiply it by 100 and round to 2 decimals, which gives us a value of 3.81%. All right, so that's how you'd calculate the percent error of a particular measurement, knowing the accepted value. And just remember, you need to calculate that error. You need to take the absolute value of the error. So it doesn't matter if it's positive or negative, it's going to be a positive number. Divide that by the accepted value, and to get it into a percent, you need to multiply it by 100. Now, I need you to do problems 2, 3, 4, and 5 on your own. I hope you have enjoyed this particular episode, and as always, if you haven't done so already, make sure you subscribe.